Welcome to Networks Professionals.
All right, welcome. Today we're cracking up in the playbook on machine learning. You hear about it everywhere, but we're going to demystify how these super powerful systems actually learn. We'll cut through the jargon and turn it all into concepts that, just make sense. So let's just get right to it. The big question on everyone's mind. How do machines actually learn? I mean, really, what's going on under the hood? It's definitely not magic, but it's a pretty fascinating process that comes in a few different flavors. Let's break it down. Okay, so here's our game plan. We'll kick things off with the core methods, then jump into some of the newer hybrid approaches. After that, we'll look at the tools that make everything smarter and faster, and we'll wrap up by looking ahead. All right, first up, the three big pillars. These are really the foundation of pretty much all of AI. If you get these, everything else we talk about is going to click into place. So, let's talk about supervised learning. The best way to think about this is like studying for a test with a huge stack of flashcards. The machine gets data that's already labeled with the right answer, like a picture of a cat with the label cat. It studies thousands of these, learning the patterns so that when it sees a new picture, it can predict what it is. This is exactly what's powering things like your email spam filter or a website's home price predictions. Next, we have unsupervised learning. Now imagine this. You dump a giant, messy bin of Legos on the floor. All different colors, all different shapes. And you just tell the machine, sort these. You don't give it any instructions. That's unsupervised learning. It's all about giving the AI a jumbled up data set and letting it find the hidden patterns and structures on its own. A classic example is when companies use it to discover groups of similar customers for marketing. And our third core method is reinforcement learning. This one is so much like training a dog. Seriously. You have an AI agent that takes actions in a digital world. If it does something good, it gets a reward, like a digital treat. If it messes up, it gets a penalty. And it does this over and over, millions of times, until it figures out the absolute best strategy to get the most rewards. This is how AIs master incredibly complex games or learn to control a robotic arm with precision. Okay, so let's quickly recap that. Supervised learning, it's all about predicting things using labeled data. Unsupervised, finding hidden patterns in unlabeled data. And reinforcement learning is about an agent learning through trial and error to get the biggest reward. See how they each have a totally different goal and data setup? The really cool part is that in the real world, these often get mixed together. You might use unsupervised learning to find customer groups and then use supervised learning to predict what each group will buy. Now, those three core methods are super powerful, but let's be real. The world is a messy place. Sometimes you don't have enough labeled data, or you have huge privacy concerns. So naturally, the field evolved. We started to see these new, more flexible solutions that kind of blend the boundaries. And that brings us to semi-supervised learning. This is just a really pragmatic, best of both worlds approach. I mean, think about it. Why spend a fortune and thousands of hours labeling every single medical image you have? With this method, you just label a few. The model then uses what it learns from that small labeled set to figure out the rest of the giant unlabeled pile. It's just a super efficient way to get amazing results without breaking the bank. Okay, this next one, is seriously clever. It's called self-supervised learning. The model literally creates its own homework and its own answer key. For instance, it'll take a sentence from the internet, blank out a word, and then its job is to guess the missing word. By doing this over and over and over, it starts to understand the deep structure of language, all without a single human ever having to provide a label. It's pretty brilliant.
So you might be thinking, okay, they sound similar. What's the real difference between semi-supervised and self-supervised? Well, it's simple. Semi-supervised still needs a little bit of human help, a small set of label data to get started. But self-supervised, it needs zero human labels. It's completely autonomous, creating its own puzzles to solve from the raw data.
But what about privacy? This is a huge one, right? And that's where federated learning is a total game changer. This approach allows a model to learn from the data on millions of phones without that personal data ever leaving your device. Your texts, your photos, it all stays put. So how does that even work? Well, here's the process. A central generic model gets sent out to everyone's devices. Then the model trains locally on your phone using your data. Here's the key part. Only the updates to the model, the improvements it made, are sent back, not your data, just the learnings. It's an amazing way to train a powerful model collaboratively while keeping everyone's privacy locked down. And why start from scratch every single time? That's the idea behind transfer learning. If you've already trained a massive model to identify cars, it already knows about things like wheels and windows and headlights. So you can take that knowledge and transfer it to a new task, like identifying trucks. It gives the new model a massive head start, making learning way, way faster. It's all about not reinventing the wheel.
Okay, so we've covered all these different ways a model can learn, but how do we make sure it learns well? How do you go from a decent model to a truly world-class one? That's where we get into the optimization toolkit, the techniques that make everything smarter, faster, and more accurate.
This first one is all about smart collaboration between human and machine. It's called active learning. Instead of a person just randomly labeling data, the model itself points to the examples it finds most confusing. It basically raises its hand and says, "Hey, human expert, I'm really not sure about this one. Can you help me out?" This means the expert's valuable time is spent on only the trickiest cases, which makes the whole training process incredibly efficient.
Next up is ensemble learning, and the idea here is pure wisdom of the crowd. Why rely on just one expert opinion when you can ask a whole committee? Ensemble learning literally trains a team of different models and then has them vote on the final answer. And there are clever ways to do this, like bagging or boosting. The bottom line is, the combined prediction of the group is almost always way more accurate and reliable than any single model on its own.
So, what if you're not a PhD in data science? Does that mean you can't use machine learning? Not anymore. That's what AutoML, or automated machine learning, is all about. It automates all the super complex, time-consuming parts of building a model, like picking the right algorithm or tweaking all the little settings. It basically makes the power AI accessible to way more people and businesses, which is a huge deal.
Whew! We have covered a lot of ground, from the fundamental building blocks all the way to the advanced tools shaping the future. So let's do a quick recap of our field guide, and then I want to leave you with one final thought.
And here it is, your whole field guide on a single slide. You've got your core methods, supervised, unsupervised, and reinforcement. Then you have the hybrid approaches that solve modern problems. And finally, the optimization tools that take good models and make them great. This is really the mental framework you need to understand how machines are learning today.
And that brings us to the big, final question. We've seen how machines are getting better and better at learning on their own, with things like self-supervised learning. So, what does that mean for us? As they become more autonomous, what's our new role in this partnership between human and machine? It's something we'll all need to think about.
Thanks for watching.